So we're going to start talking about, excuse me, addition of organometallics to carbonyl compounds. All right. And so up top, what we have is, and if you have the handout, you have this, so you don't have to worry about trying to scribble it down. But what we have is an example of a reaction. And I want to go through the pieces of this, beginning with the start materials and the process and then the product. So for your start material, you're going to have either an aldehyde or a ketone. You can add to an acid or ester, but mainly if you want to add a granular to a carbonyl, it's going to be an aldehyde or a ketone. All right, so you have that. You have your granular right here, right? Your organometallic, and then there's always a second step in the reaction that we call a quench. Right, all this does proton transfer. With oxygen. And when I show you the mechanism, you'll see what I'm talking about. Right, so you have the quench step after you add the organometallic, and then your final product, in this case, is an alcohol. Right, if you watch the video, then you know that there is a mnemonic that I gave you for addition of a granular to a ketone or an aldehyde, right? So this mnemonic was for granular to an aldehyde or a ketone gives you an alcohol, right? That's always the product of granular addition to carbonyls, to aldehydes and ketones. So if you look down the mechanism, remember we talked about the granular, and we said that, sorry about that, the granular itself is a nucleophile, and it's the carbon and the granular that's nucleophilic. So that carbon is partially negative, the magnesium is partially positive. And so it's it's the electrons in that carbon magnesium bond that are being used to attack, right? So this is a addition reaction, and it's that carbon that's attacking the carbonyl. So you can see the arrow going to here, and you break the carbon oxygen pi bond. Right? Anytime you do an addition to, excuse me, a carbonyl, you get an intermediate. Right? In this case, we call any carbonyl addition. You add a nucleophile to it, you're going to get what's called a tetrahedral intermediate. Which is here, right? You could also write that like this. Let me just redraw it. So oxygen is negative. I'm just going to abbreviate that ring as pH. So that's negative. And then the magnesium is here, MgBr, which is positive. So that magnesium actually forms a salt with the oxygen. But then in the quench step, which is here, right? Remember, oxygen has 3 lone pairs of electrons, so it's going to attack that proton. So it's just going to attack like that and generate your alcohol. All right, so it's that plus And I'm going to put let me just put Y right here, because that proton had to come from somewhere. So whatever the acid is, the conjugate base of that acid is going to end up in a salt with magnesium. Right, so H+.
What does the Y mean again?
Go ahead.
What does the Y mean again?
All right, let me write that in. So Y is the conjugate base of your acid.
Thank you.
So whatever your acid is, where H+ is coming from, that conjugate base. Let's say, for instance, this is, we add HCl, right? So the Y part is going to be chlorine, which is the conjugate base of HCl, right? And so most of the time when you add an acid at the end, in the quench step, it's going to be something like HCl, or it's going to be acetic acid, which is HOAC, or it's going to be something like ammonium chloride, which is NH4Cl. So those are just some typical acids that you add to quench these reactions. Right, so H+ can be any of those. It can be HCl, it can be acetic acid, ammonium chloride, it can be HBr. You really just need a weak acid. Any weak acid will do, because that oxygen is really, really nucleophilic, but it's also pretty basic as well. So it can attack that H+, right? And then my end result is always here, an alcohol, right? Let me wipe that. I don't know where that came from. All right, any questions about that? Right, so in that mechanism, again, the first step is addition. All right, remember, anytime you react in a pi bond with some nucleophile, you get an addition reaction, because you're going to end up breaking that pi bond. So there's addition, you get the intermediate, and then the final quench step is just a proton transfer. All right, questions about that addition? All right, let's take a look at, we're going to do examples, example 1 and example 2. I'm actually going to cut example 2 out, because we can talk in detail about that. All right, for now, let's go back to the first example. All right, so I have what functional group is that in number 1? Right here. Is it an aldehyde? Is it a ketone? Is it an ester? Is it a carboxylic acid? Is it an amide? What functional group is that?
Ketone.
Thank you. It's a ketone. All right. I'm gonna say this up front. With this class, if there are gaps in resonance, arrow pushing, or identifying functional groups, this whole section and everything after this is going to be a struggle. So you got to refresh yourself on those functional groups. One of the key things for these mechanisms is identifying the functional groups, especially for this section. So you got to refresh yourself, go back, get your flashcards that you made in part 1. If you didn't make them, get the flashcard app on your iPhone or on your Android and quiz yourself on those functional groups. If you don't recognize the functional groups, none of the chemistry part is gonna make sense. All right, so we gotta get those basics so we can move on to like the advanced stuff. All right, so there's an app in the Apple Store and in the Play Store. There's an app for functional groups, and there's also an app for different name reactions. So my suggestion, if you're still struggling with that part, you need to get that. All right, so that's my ketone, and this is my Grignard, and it's going to be this carbon in the Grignard that reacts. Right, remember this is the key to these reactions, is to know that the Grignard is a nucleophile with a dipole in that direction towards magnesium. Right, so it's always the carbon in the Grignard that attacks the carbonyl. Right. So now we know where the electrons are coming from, because now this is all just nucleophile electrophile chemistry. The fact that the carbonyl is polarized this way and this carbon is partially positive. This is backwards. Sorry about that. And the oxygen is partially negative. That's how we know where to attack, because this is my electrophile. And over here, my Grignard is my nucleophile. All right, so what are the arrows going to look like for this reaction when that Grignard attacks the ketone?
The arrow's going to go from the carbon on the Grignard to the carbonyl, and then the oxygen is going to break off.
Good. So my arrows are going to look like this. I'm actually going to start my arrow here at the bond, because that's where the electrons are actually coming from. All right, so I'm going to take this arrow, I need to zoom out a little. Take this arrow right here and push it here, just like that. That's not what I meant to do. Sorry. All right, and then I'm going to take the carbonyl, the pi bond on the carbonyl, and push it to oxygen. Let me put some lone pairs in. So this has 2 lone pairs already. All right. So now that's going to get me to an intermediate. And I'm just going to redraw this part. Come on, Russell. So my oxygen is now negative. I have a CH3 attached to that. I'm just going to keep it just how it is. And then I also now have this whole chain attached. So that's 4 carbons. So I'm just going to write that out. I'm going to change the color. All right, anybody not seeing that? So when that carbon from the granular attached to carbonyl is taking the whole, everything that's bonded to it is going with it. And then with the oxygen, my magnesium is now here, and it's a salt. So Mg, that's positive. The oxygen is negative. Questions about that part? And I'm going to change this. I'm going to make this ammonium chloride because H3O plus is kind of ambiguous, and I always get a lot of questions about that whenever I'm teaching this section. So we're just going to make it ammonium chloride. All right. What's next? So that happens in step 1. And then I go to lunch and I come back and then I do my quench step. All right. So I'll show you how that works. So step 2 again is for quenching. All right. So I'm going to take that ammonium chloride, which looks like this. So it's a nitrogen with 4 hydrogens on it. And that's positive, and it's a source of salt with nitrogen, the ammonium cation, and then a chlorine anion, right? So this is just a simple proton transfer. Right, so in this case, let me just redraw this. Okay. So we have I'm gonna change the color on this just to make it to where you can follow where all the atoms are going. So we have that plus NH3 plus ClMgI, right? All of this right here, trash. We don't care about it. It's during the workup part. The only thing you care about is the product.
I have a question.
Go right ahead.
For the first problem, the example problem,
Mhm.
the mechanism for the intermediate, why did the oxygen from the carbonyl join with the granular, but in the one we just didn't do that?
You mean the magnesium?
Yeah.
It did. I have it here in green. It just makes a salt with the metal. So the magnesium, once the granular attacks, the magnesium is kind of just in solution, and the oxygen becomes negative. So they form they have an ionic attraction between each other. Can you see it right there? Where I have it in the magnesium in green?
Yes.
Oxygen, it's the same. It's not, I have it, the way I have it written up here, it looks like it's covalent, but it's not covalent. It's actually an ionic attraction. So the oxygen is negative, and then that's why I drew it like that down here. So the oxygen is negative, and then the magnesium is positive. Does that answer your question?
Mm-hmm.
Okay. All right. All right. So that's my alcohol. Again, anytime you add a granule to an aldehyde or a ketone, you're going to get an alcohol. All right. What functional group is this here? Any other questions about number 1 before we move to the next one? All right, what functional group are we working with here? In number 2.
Is it an ester?
It's an ester. That's exactly right. If you watch the Grignard video that I sent, what's the mnemonic for when a Grignard reacts with an ester?
Heat? Is it heat?
What does that mean? So a Grignard plus an ester equals what?
Is it Grignard
Uh-oh.
ester equals ketone?
It's a ketone, yes. I'm sorry. I don't know why my screen dropped, but let me fix it. I ordered a new hotspot. It should be here tomorrow because I can't keep dealing with this AT&T stuff. Oh, come on. Hold on a second. Come on, bro. Ten seconds for station identification. Because this is, let me pause the recording too.